Welcome back to Geometry Chapter 9, Section 5 in this book. But you don't have to be having this book to understand that we're going to learn about trig ratios. There you go. So I told you before that we didn't have to learn the special triangles because we were going to use trig. Today's the day you finally get to learn. Okay, so first of all, you have to learn the parts of a triangle. You're like, I already know them. Leg, leg, hypotenuse. We're going to call something a little bit different this time, because why we want to know this is if we know an angle and one of the three sides of a triangle, using trig, we can find out all the angles and all the other sides. Now, right now, we are going to only do right triangles. In Algebra 2, we'll learn what to do if it's not a right triangle, but for now, it has to be a right triangle for this to work. So there are these ratios built in to the relationship between the angles and the sides of a triangle. And so it's this new math called trig. And so this is how it works. Here I have a triangle. The longest side is the hypotenuse. Easy enough. Now, I have an angle here. If you have an angle that is unknown, we don't call it x, we call it this. It's a circle with a line through it. It's the Greek letter theta, and that's what we use for angles instead of an x. You'll notice on your calculator the button that has x on it, next to x is t, and then theta, there it is. That lets you know that that for in certain situations, that instead of using an x, we use a theta. So that's our unknown angle. This is the angle we're working with. So on this triangle, the vertices are A, B, and C. They named the side across from angle A, side little a. The side across from angle B, side little b. And the side across from angle C is side little c. Now, this is our unknown angle, theta, and we have to know what to call the sides besides A, B, and C. And the longest side is always called hypotenuse. Whew, we know that one. Okay, well, what about the other two? The one that's not the hypotenuse, that is next to theta, is called the adjacent. You might have heard of like an adjacent lot to a building. It is a lot that is next to the building. So adjacent means next to. So adjacent is next to theta. The other one is called the opposite, because if this is a trumpet going out, opposite is across or opposite from theta. Okay, now, the next thing we have to learn is a little bit of barnyard drama to remember our trig ratios. And this is it. Imagine the barnyard. Imagine the drama. Some old horse caught another horse. Oh no! Taking oats away. We need Sherlock Horse to come solve this. Okay, so this is how we're going to memorize it. Some old horse caught another horse taking oats away. Some people do so, ka, toa, with the very first letters, but I've tutored kids and they go, I don't remember it. It's something about Indians or toes or something. So forget all that. We're going to do some old horse caught another horse taking oats away. You can imagine the drama. We need Sherlock Horse. Okay, why do we have to know about the horses? We're going to use these letters to memorize the formulas. The sine of theta is the opposite over hypotenuse. Okay, we're just learning it now. You'll see it in a second. The cosine of theta is the adjacent over the hypotenuse, and the tangent of theta is the opposite over adjacent. Some old horse caught another horse taking oats away. Now, what do you do with all this? Well, this is how it works. I guess we'll do that one next. Okay, so if we know theta, this is our theta, then we can put it into this formula and we can have a ratio that tells us some stuff about the relationship. So the sine of theta is the opposite. The opposite of theta is A, and here it is 8. Okay, see how A equals 8 in this scenario. Over the hypotenuse is C here, and it is 17. So we have this relationship that the sine of theta is 8 over 17. we can actually take that relationship, put it in our calculator, and it will tell us what theta is. We're not going to do it today. Your book wants to break it down into baby steps and not teach you how to get theta yet. All they want you to know is how to put it into the formula. Okay, let's do the cosine. The cosine caught another horse. The cosine is the adjacent, that's B, 15, over the hypotenuse, that's C, 17. We're using these numbers right here. Okay, and then for the tangent, taking oats away, the tangent is the opposite, A, which is 8, over the adjacent B, which is 15. And we can use those fractions, put them in our calculator, and we can actually get theta and find out what it is. Okay, so this is our big triangle. We figured out the relationships. Now let's do it with the small triangle. Let's practice it again. Some old horse, so I'm going to go ahead and write these down. The hypotenuse, I'm going to write down as 8.5. The adjacent, I'm going to write down as 7.5. And the opposite is 4. So I think that'll be a little easier to do with this small triangle. So opposite over hypotenuse, opposite is 4 over hypotenuse, which is 8.5. Adjacent over hypotenuse, adjacent, on our small triangle is 7.5. Over our hypotenuse, it's still 8.5. And then for the tangent, it's opposite 4 over the adjacent, which is 15. Now, why do we need 3 formulas? Because they're all kind of using the same thing. It's because you're given different things. If you're given one side and angle, you can solve the whole triangle. So, or here we have to have, eventually. But, so that's why we have to have the different formulas, is because these are kind of word problems and we're given different things. Alright, so here's another one. Let's practice with this one. We have a triangle. It's 5 on this side, 12 on this side, and 13. And first they want S to be our theta. So we're going to figure it out. So it's sum, and I'm going to just do the letters. Some old horse is our sine of theta equals opposite over hypotenuse. This is theta. So opposite is 5 over hypotenuse. Hypotenuse is 13. Caught another horse. So now we want to do adjacent, which is 12, over hypotenuse, which is 13. Taking oats away. So now we do opposite is 5 over adjacent, which is 12. So those are my 3 fractions that I'm writing down. And eventually we're going to be able to get the angle from it. Okay, so now we're going to change it. And R is going to be our theta. Alright? So now, some old horse, for R, the opposite, do you see, is 12. But the hypotenuse is always the hypotenuse, it's 13. Caught another horse, for this being our theta, the adjacent is 5. Over the hypotenuse, still 13. Taking oats away. The opposite is 12. The adjacent is 5. And this might take a little bit of practice and you looking at it, but that's what's going on here. Alright, now we're going over here. So here, this one, they've got a 45, 45, 90 triangle. The two sides are 1, and the square root of 2 is the hypotenuse. So, some old horse, and our theta is 45. So the sine of 45 is the opposite 1 over the hypotenuse square root of 2. Now, what I want you to do on your calculator, I want you to turn it on. I want you to push that button that looks like sin, but it's sine. And then I want you to put in 45 and enter. And you get 0.7071 ... Now I want you to put this in your calculator. 1 divided by the square root of 2. And definitely done, it's the same thing. So this is showing you that sine of 45 and this fraction is the same thing. Same thing with cosine. Cosine of 45, put it in your calculator, and because this one is all even, it ends up being the same thing, 0.7071. And then the adjacent over the hypotenuse caught another horse. So the adjacent is 1 and the hypotenuse is square root of 2. So it's the same thing. Taking oats away, so the tangent is the opposite over the adjacent, 1 over 1, which is 1. Putting your calculator, tangent of 45, enter, and it will say 1. Okay, same thing with this one. They showed you with a 45, 45, 90, and here is a 30, 60, 90. Our theta this time is 30. That's our thing. And so we know that the sine of 30 is 0.5, the cosine of 30 is 0.866, and the tangent of 30 is 0.577. If you put it on your calculator, that's what you'll get. But you can also do it the other way. Some old horse. So the sine of 30 is the opposite 1 over the hypotenuse 2, 0.5. The cosine of 30 is caught another horse, the adjacent over the hypotenuse, square root of 3 over 2, 0.866. Or, taking oats away, the tangent is the opposite over the adjacent, 1 over the square root of 3, 0.55. You get the same thing either way. Now there are a couple of things called trig identities. You will need to memorize these when you get to probably Algebra 2 in college. For now it's just interesting. If you take an angle and you do sine of 30 squared plus cosine of 30 squared on your calculator, it equals 1. No matter what the angle is, it ends up being 1. Okay? And the other one is that the tangent of an angle is equal to the same thing as the sine of that angle divided by cosine. So on your calculator, do tangent of 30, see what that is, and then do sine of 30 divided by cosine of 30, and it'll be the same thing.